Okay, so that was it, chapter 5. Okay, and well, there were a couple of topics. Chapter 5, section 5.6 and 5.7. 5.6 is just three-dimensional, right? And you do exactly the same thing, right? Same equations, and just do it in 3D. That's it, right? And then from a moment, okay, just take moment about x, y, and z axis. Okay, and we discussed that before, right? So how to take moment about an axis. Okay, so and the last section, is about constraint and being statically indeterminate. So it's just extra reading for you to do. Okay. So let's review everything we've done so far. Okay, just so that you're ready for exam 1. Okay. So we've done particle and rigid body. Okay. For particle statics, there's only one equation. Sum of forces equals 0. That's all. It's a vector equation. Okay. So you need to recognize that whether the problem is two-dimensional or three-dimensional, okay, and what coordinate system is most useful. Okay. So if you choose Cartesian coordinate system, x, y, z, then you have these three components, okay, of this equation. So each of these equations now is a scalar equation. Okay, so now you can expand left-hand side by looking at your free body diagram. Okay, so very important. Free body diagram rules statics analysis. Okay, so got to really start off with free body diagram, and then you apply the equations to your free body diagram. So the equation is very, very straightforward, and you might need a few other things to help you analyze the problem. Vector properties, right? Talked about it a lot in chapter 2. Geometry, okay? So trigonometry, for example, right? Or similar triangles and things like that, right? And also we talked about dot product, okay? So two vectors dot together, what does that mean, right? So this is quite straightforward, but this lays the foundation for rigid body, right? Now rigid body now involves rotation or the tendency to rotate, okay? So in order for a rigid body to be in equilibrium, it must satisfy two equations now, okay? Sum of forces as well as sum of moment, okay? Sum of forces just like particle, right? So we can have three components in three-dimensional space, right, and Cartesian space, x, y, z. Sum of moment, okay, must also be satisfied. Okay, the sum of moment, okay, is defined R cross F, and in three-dimensional space, then you can take moment about each of the principal axes, x, y, z axis. Okay, and here major difference is moment. Right, so we spend a lot of time talking about moments, okay, as well as couples, okay. So it's couples, right, and also a few other auxiliary things that will help you analyze rigid body problems. Again, vector properties, geometry, cross products now, okay, because we do a lot of cross product in talking about moments, right, R cross F, right, and things like that. As well as couples. Okay, so we'll talk about different kind of couple force systems and how to reduce them. Okay, so all these, okay, there aren't a lot of equations. Okay, not at all. Right, the main equations are just sum of forces and sum of moment for a rigid body. That's all. Right, and how you develop, okay, and apply these equations to your free body diagram. Well, you're going to need some of these things, right? And the rest is just pure math, okay? So, but once again, free body diagrams rule the analysis of statics, okay? So you must always start with free body diagram, okay? And then, right, think about whether it's particle or rigid body, okay? Whether there's rotation, right, or the tendency to want to rotate or not. If not, then particle? If so, then it's rigid body, right? And then just develop equations there. Okay? And that's it. These are the equations needed, and things like the reaction forces, right? What kind of reactions exist as student support. There's a table, right? That will be given to you, right? And the main equations, well, you're expected to know them, right? Because these are really the bread and butter is statics, right? So you have to know these by heart, okay? The definition of moment, okay, and couples, for example, right? So you should know that too, okay? So any other extra equation will be given to you, right? Do all the homework, okay? All the homework assigned to you, you should go through them, okay? At least try them, right? Do it yourself first, and then bring it to your friends and sit down together and discuss, right? And ask the TAs, okay, in class. And in the back of each chapter, there's review problems, and there's also a little summary also. It'd be good to go through them as well. All right? So, that's it.